Okay, so looking at the last digit, it is divisible by 2 if it ends with 0, 2, 4, 6, 8, or another 0. I only need one. But that makes it a what kind of number? Even. All even numbers are divisible by 2. How do I know if a number is divisible by 5? 0 or 5? How do I know if a number is divisible by 10? Last digit is a 0. Now, this is where we don't just look, we have to do something. So, to see if a number is divisible by 3 or divisible by 9, we're going to be adding the digits together. So, for this, the sum of the digits, if the sum is a multiple of 3 or divisible by 3 with no remainder, then 3 will go into that number completely. If the sum of the digits is a multiple of 9 or divisible by 9, with no remainder, then 9 will go into that number. And then we have some that are a combination. We can figure out a number is divisible by 4 if it's divisible by 2 twice. If we divide by 2 and we get an even number, then 4 is going to work. If we divide by 2 and we get an odd number, can we divide 2 into an odd number? Then that means 4 is not going to work. Finally, 6 is if you have 2 and 3. This is going to make more sense when we actually work out the problem. So, is 86 divisible by 2? Raise your hand if you say yes. Raise your hand if you say no. So, a lot of people didn't say anything. Let's go back. How do I know if a number is divisible by 2? What are we looking at? We're looking at the last digit. What is the last digit of 86? It's a 6. Is that making it an even or an odd number? Even. So is 86 divisible by 2? Yes. It's yes. It's yes because ends with a 6, or we can put it's an even number. Either of those are reasons for that. It ends with a 6 or because we have an even number. Now, is 53 divisible by 3? Let's go back. How do we decide if a number is divisible by 3? What do we have to do? Sum of the digits. So on the line, let's put our digits. What are the digits in the number? What are the digits in the number? 5 and 3. What am I going to do with them? Add them together. So if I add them together, what do I get? 8. Does 3 go into 8 evenly? So this is a no. That means 3 will not go into 53 evenly. It has to add up to a number that 3 will go into that's either a multiple or divisible by 3. All right, next one. Is 70 divisible by 5? Let's look at our list. How do I know if a number is divisible by 5? 0 or 5. So let's go back. Is 70 divisible by 5? Yes, why? It ends with 0. I'm not going to say that it's even, because 5 does not go into all even numbers. It goes into some even numbers if it ends with a 0, but not because if it's even, because 5 has lots of numbers that are not even. Half are even, half are odd, because it either ends with a 5 or a 0. All right, is 68 divisible by 4? Takes a little bit of work. So we have to see, first, does 2 go into 68 evenly? Okay, so how many times does 2 go into 68? How many times does 2 go into 6? 3. How many times does 2 go into 8? Okay, now, it went once. When I get this answer, is this an even or an odd number? Even. Can I divide this by 2 a second time? Yes. If I can divide by 2 a second time, the answer is going to be a yes. If I get an answer like 33, can I divide 2 into 33? If it's no, then this would be no. I have to be able to divide by 2 twice. That's what we have here. Can you divide by 2 twice? Questions? All right, so. Sir? Which value is 60 divisible by? Am I going to circle the 1? Yes, because what do we know? All numbers are divisible by 1. So I'm going to circle the 1. Got some people not writing this down. That's concerning. All right, so I have 60. Is 60 divisible by 2? Why? Ends with a 0. Is 60 divisible by 5? Why? Ends with a 0. Is 60 divisible by 10? Why? Because it ends with a 0. So if it ends with a 0, you're going to have 2, 5, and 10 every time. Okay. Is this divisible by 3? What do I have to do? Add the digits together. So what are my digits? 6 plus 0 equals what? Does 3 go into 6 evenly? Yeah, so that means 3 will go into 60 evenly. It would go 20 times. The same thing. So both of these numbers are sum. You're adding the numbers together. So I have a 9. Does 9 go into 6 evenly? No. So I'm not going to circle it. It has to go into that number evenly. All right, let's do 4. First, can I divide 60 in half? Okay, what do I get? Is that even or odd? If it's even, can I divide by 2 again? So I'm going to circle the 4 because I can divide it by 2 and get an even number. Okay, how about 6? Should it be circled? So what do I do for 6? What do I have to do for 6? And 3. So for this one, it's 2 and 3. Do I have the 2 and the 3 circled? So then I circle the 6. Questions? All right, we have 75. Is it divisible by 1? Yes. 2. Why not? Ends with a 5. Is it divisible by 5? Why? Ends with a 5. Is it divisible by 10? Why not? Ends with a 5. Has to end with a what to be divisible by 10? Has to have a 0. How about 3? What do I need to do to figure out the 3? I have to do what with the numbers? Felix, you're not paying attention. What is 7 plus 5? What's 7 plus 12? Does 3 go into 12 evenly, or is 12 a multiple of 3? Yeah, so it should be circled. Because 3 times 4 is 12. Am I going to circle the 9? Does 9 go into 12 evenly? Does 9 go into 12 evenly? If I look under the 9's tables, do you see the number 12? No. Yep, not there. Now, am I going to circle the 4? Can I divide by 2 twice? You're not looking at the sum. You're looking at, no. If I don't have the 2 circled, I'm never going to circle the 4. To be the 4, you have to have the 2, and you have to be able to divide by 2 again. How about the 6? Why not? Because you don't have the 2. You got the 3, but it has to be 2 and 3. All right, 56. Is it divisible by 1? Why? All numbers. How about 2? Why? Because it ends with a 6. It's even. How about 5? Why not? It doesn't end with 5 or 0. How about 10? Why not? All right, how about 3? Let's go back. How am I going to figure out 3? What do I do with these numbers? What's 5 plus 6? Does 3 go into 11 evenly? If you look under the 3's, is there an 11? No. Am I going to circle the 9? If I don't circle 3, I'm not circling 9. Okay, now sometimes I'll circle the 3 and not the 9, but if I circle the 9, the 3 has to be circled. Okay, because all of the 9s are also going to be multiples of 3. How about 4? So let's look. If I divide 56 in half, this is what I do. I break it up into easier numbers. What's half of 50? 25. What's half of 6? Okay, what's 25 plus 3? Is 28 an even or an odd number? So can I divide by 2 again? Now, if you can't remember that, you can always go to the bottom and do what with 4? Divide it into 56. How many times does 4 go into 5? Once. When I subtract, I get 16. How many 4s are in 16? And notice I have no remainder. So 4 times 14. It's not on our chart because our chart only goes to 12 by 12. Questions? All right, so the 4 circled. Am I going to circle the 6? Why not? Didn't circle the 3. In order to circle 6, you have to have the 2 and the 3. All right, 126. Am I going to circle the 1? Am I going to circle the 2? Why? It's an even number. Am I going to circle the 5? Am I going to circle the 10? Okay, any questions why? Does not end with a 0. It does not end with a 5 or 0. How do I figure out the 3? What do I have to do? Felix. What do I do with 126? What is the sum of the digits? What are the numbers? 1 plus 2 plus 6. What's 1 plus 2 plus 6? 9. Does 3 go into 9 evenly? So it should be circled. Does 9 go into 9 evenly? It should be circled. Am I going to circle the 4? I don't know. What am I going to have to do? What's half of 126? What's half of 126? Okay, so if you can't figure that out with mental math, which it seems to be difficult for many, you can divide by 4. Does 4 go into it evenly? Does 4 go into 12? How many times? 3. Got a lot of people not writing this down. Not sure why. If I'm writing, you're writing. These are your notes. So I get a 0. I bring down the 6. How many 4s are in 6? How many 4s are in 6? 1. So when I multiply, do I have a remainder? I have 2. So does 4 go into 126 evenly? No. How do I know that? There's a remainder. If it's divisible, you can't have anything left over. Okay. Am I going to circle the 6?
Yes.
Why? Because I have what circled? The 2 and the 3. So I'm going to circle the 6. Now, this is a review because Monday was kind of rushed. You have homework on this again. So I want to make sure that you have it. You're going to open up your notebooks to page 35A. On page 35A, we did this review. This is on divisibility rules. Alexis, can you answer the phone? Okay, you're going to take and put this at the top. This is 35A. You are going to then get a stapler. That's good. So, you are going to staple. 2 staples only, please. This is not for you to put 10 staples in. Alexis, who's thinking?
Anaya needs to go to the office to pick something up.
She just needs to pick something up. Anais, you need to go to the office and pick something up. Go quickly because we're not waiting on you. Okay, please just 2 staples. If you do more than that, I'm not going to have enough staples for the year. This is not for you to play with the stapler. I had to only in one class go and help a young man who just was so mesmerized with my tool, he just could not use it appropriately. So I did it for him. If you feel that you don't know how to use a stapler, let me know and I'll help you out. Okay, you're going to do 2 staples at the top. On page 35A, you're going to staple this when it comes to you. Please do not wait for the stapler to engage your notes. You're going to keep going with the notes, and you're going to stop just for a second to put 2 staples in this and then move on. Okay, so please don't sit and wait because we're not waiting. So it's going to go around. You're going to staple it, and then you guys are going to pass it that way, and then let's see, from there, it should be on that new note page. Kezias, you're going to then, when you get it from Baylin, then you're going to give it to Jackson. Jackson, you're going to pass it to the next table, and it's going to keep going until it comes around. All right, so we're going to look on page 35B. On page 35B. Okay, I am going to be using markers. You do not have to, but we're going to be doing the chart at the bottom. To do that, we need to talk about 2 numbers. Bring me your computer. All right, so a blank number has exactly 2 factors. Thinking back to 5th grade, what are numbers called that have exactly 2 factors? Go quickly. Shh, thanks for raising your hand. It's going to be what? Shh. If it has exactly 2 factors, what are they called? It's going to be what, Rowan? Prime. So we're going to put prime. Make sure you're filling this in. A prime number has exactly 2 factors, blank and itself. So, and we did this with our factors, Summer. It's going to be 1. So you have prime numbers have only 2 factors, 1 and itself. We're going to go this way. Cassidy, sorry, dear. It's going to go this way, and then it's going to come around to you. So, did everybody get it at this table?
Yeah.
Okay, you're going to pass it behind you. That way nobody has to get, thank you. And then it'll come to you, and then somebody at that table will bring it to me for whoever's the last one. Okay, we have prime numbers, and we also have these numbers. It's either prime or it's going to be what? Composite. So, a composite number has more than 2 blank. Has more than 2, Chloe. Good, factors. All numbers can be identified as either prime or composite numbers except 1 because of this reason. Why is 1 not prime, not composite? Look at our definitions. Why is 1 going to be not prime, not composite? Chloe? So I want you to think about, we're not talking about divisibility, we're talking about the factors. So factors are numbers that we multiply. How can we get 1? How do we get 1? Think of your multiplication tables. Look at the chart on the board. How can we get 1 as a product? What number can I multiply? 1 times 1. 1 times 1 equals what? 1. How many factors does 1 have? It has only 1 factor. It has only 1 factor. To be prime, it has to have exactly 2. To be composite, it has to have more than 2. 1 does not have enough. It only has the 1. Why is 0? 0 is neither prime or composite for a different reason. How can I get 0 for a product?
0 times 1.
Okay, so 0 times 1, is that the only way?
No. Multiply anything.
0 times anything.
Anything. How many numbers do we have? Infinite. We talked on Monday that factors are a set number. So like if I'm doing factors for a number, I can make a list and stop. Multiples are never ending. We're talking about factors. So 0 is not prime or composite because the factors are endless. Okay? No matter what number you multiply it by, you're going to get 0 as an answer. That is a property. Write this down. Write this down on this page. That property is called the multiplicative property of 0. That says any number times blank equals blank. Felix, what am I going to fill in the blanks? Any number times what is going to equal the same thing?
Any number times 0.
0. And if I multiply by 0, what do I get? 0. So when I multiply by 0, I'm going to get 0 for an answer. Question. Now, we are going to identify, this is from 5th grade. We are going to identify prime and composite numbers from 1 to 100. Okay, looking at the beginning, we are going to circle prime numbers, and we're going to mark out the composite numbers. So we're going to start at the beginning. Is 1 prime or composite? You're only going to put 2 staples in. So is 1 prime or composite? What do we say about 1? It's neither one because it has only one factor. So where it says 1, we're going to put neither. We are not going to mark it out. We are not going to circle it. It is neither one. First number after that is a 2. How can I get 2? 2 times 1. Is there any other way? It has exactly how many factors? 2. So it's a what kind of number? Prime. It should be circled. It's an even number. We know that even numbers are divisible by 2. If it's divisible by 2, it means it's going to have more than 2 factors, making it what? Composite. So if I have times 1, I have 2. What about times 2? Please quickly staple the papers. It seems to be a distraction with the stapler. Staple so you can get your focus back on. If I am marking out composite numbers, is 4. If I'm counting by 2s, the 4 is going to be what? How can I get 4? Okay, we're multiplying, not adding. 1 times 4 and 2 times 2. Does it have more than 2 factors? So, it's composite. We're marking it out. We're going to skip count by 2s. Everything that's a multiple of 2 is composite. Baylin, pay attention. So, I mark out the 4. What do I mark out next? Mark out the 6. What's next? Then? 18 and 20. What's after 20? 22. 24. Do you see a pattern?
Yes, I do.
You can just go all the way down the column and you're marking out every even number except the 2. All of these are composite because it has 1 and itself and the number 2. That makes it having more than 2 factors. Everything that ends with a 2, everything that ends with a 4, everything that ends with a 6, everything that ends with an 8, everything that ends with a 0. That makes it a composite number. Now, the next number that is not marked out is 3. We know that multiples of 3, that if I add those numbers together, 3 is going to go into it. All right, so I can also skip count. So if I'm here and I do 3 numbers past 3, what's the next number? Thank you, ma'am. If I can't, I'm at 3. 1, 2, 3. What's next? All right, it's already marked out. Do 3 more. What's next? All right, mark it out. After that, I'm going to do 3 more. What's next? It's already marked out. What's next? 15. You're going to mark that out because it's not marked out. I'm sorry. I thought you had it. It was supposed to come to you. Okay, so after 15, what's next? 1, 2, 3. What's next? 18. What comes after 18? 21. Mark that out. After 21. 24. It's already marked out. There's a pattern. With multiples of 3, it's an even number, then an odd number. Even number, odd number. So after 24, what's next? Make sure 27 is marked out. What's next? 30. After 30. 33. After 33. 36. I've got some people not writing. I'm not sure why. This is not something at the end you can tell me you need more time. You're not going to be able to get it done. So you should be following along. 36 is marked out. What comes after 36? 39 should be marked out. After 39. 42 is marked out. After 42. 45. After 45. 48. After 48. 51. After 51. It's already marked out. 1, 2, 3. You got to count 3 and then mark. After 54. 57. Mark out 57. After 57. After 60. 63. After 63. Already marked out. After 66. Make sure you mark out 69. After 69. Already marked out. After 72. Make sure you mark it out. After 75. Already marked out. After 78. Mark out 81. After 81. Marked out. After 84. 87. Just going to stop for a second. What's 8 plus 7? Does 3 go into 15? That's why it's marked out. So everything we've marked out for 3, if I add those numbers together, 3 will go into it. After 87.
90.
After 90.
93.
93. After 93. After 96. 99. So we are now to our next number. Okay, so what's the next number that's not marked out? Okay, it's 5, prime or composite? It's prime. The only way to get 5 is 1 times 5. What do we know about multiples of 5? They end with a 5 or 0. Notice, everything that's even has already been marked out for zeros. Where can I find the numbers that 5 will go into? They're right under it. So underneath the 5, everything that ends with a 5 that's not marked out, you're going to mark out. So we've done all multiples of 1, 2, 3, 4, and 5. 6 is marked out because that is covered with 2 and 3. Okay? Now we're at 7. We have done everything up to 6 times 7. All of those have been marked out. Just wait. Now, what number am I going to circle as the next prime number? 7. So I'm going to circle that. I know that 6 times 7 is 42. It's already marked out. So after 42, what's the next number? What's 7 times 7?
49.
That is not marked out because we haven't done any multiples of 7. So mark out the 49. Now, we can count by 7s, or I can think of my times table. So 7 times 7 is 49. What's 7 times 8?
56.
Is already marked out. What's 7 times 9? Is already marked out. What's 7 times 10? Is already marked out. What's 7 times 11? Is not marked out. So we're going to mark out 77. Now it might be easier to count by sevens. 1, 2, 3, 4, 5, 6, 7. Already marked out. What's next? 1, 2, 3, 4, 5, 6, 7. What is it? 91 is not marked out because 7 times 13 is 91. Why wasn't it marked out? Because we haven't had any multiples of 13 yet that we could mark out. And then if I go 7 more, I'm at 98, and then I've passed the chart. Okay? Now, what's my next prime number to circle? 11. What do we know about factors of 11? Yeah, they're going to be twin numbers. So like 22, 33, 44. Notice, they're all taken care of. Now that we're to 11, everything else that's left is prime. So, I have 11. What's my next prime number? 13. What's my next prime number? 17. This is important to have your prime numbers circled. What's after 17? 19. What comes after 19? 23. Focus. After 23. 29. After 29. Notice, these do not show up in our times tables when we're studying. These are not numbers that we have to remember. After 31. 37. After 37. 41. What's next? 47. What's next? We missed the 43. Don't forget the 43. So 41, 43, 47. You're right. I missed it. Make sure you don't miss it. After 47. 53. After 53. 59. After 59. 61. Get ready. After 61.
67.
Did you know it was a prime number? Now you know. It's not in any of your times tables. It is unique. They say it doesn't mean anything. You say that's not right. It's prime. It's special. Okay? After 67. 71. After 71. 73. After 73.
79.
After 79. 83. After 83.
89.
After 89.
97.
Now, the question that we're going to end with. From 1 to 100, there are blank prime numbers. They are all circled. Raise your hand when you can give me the total number of primes between 1 and 100. Hannah, got an answer? I would count going down instead of across, but that works better for me. So you're counting. I see one hand. Anybody else have a total? I see 2 hands, 3 hands. Baylin, you have an answer? You're counting. You're counting how many you have circled. What did you get for an answer? Jackson?
25.
Anybody else get 25? Is correct. So, if you don't have 25, you might want to look again. But 25 is the number of prime numbers. 1/4 of them are prime. Okay? Which is more than I would have thought before I got started. Questions? Now, we're going to use that information on page 36A. All of you. We are going to be doing something called prime factorization. To do that, you're going to need to know the basics of exponents. We're going to get into exponents a lot more after break where we do more with them, but we need to know the basics because prime factorization deals with lots of numbers, and this is a shortcut when you have lots of numbers that have the same value. These are the basics. The exponent is the power. That tells you how many times the base is used as a factor. Okay? Sure. Now, on a number that's written with an exponent, it has two parts. It has the big number that's written, that's regular and on the line. That's called the base. The base is the number that's multiplied to itself. So this is the number we're using as the factor. This number that seems to be floating, that has extra special powers, is called the exponent. The exponent is how many times the base or factor is multiplied to itself. It's also called raising it to that power. Okay? So exponent and power are used in the same kind of meaning. So base is the big number, but this can be called the exponent or the power. There are different forms. This is called exponent form. So you're putting an exponent on the base number. So if I have 4 to the first power, I'm only going to write this factor or base one time. The product is what I get. If I have 4, what do I get? It's 4. Okay? Now, I have an answer of 16. Notice all these deal with 4s. How many 4s am I going to multiply to get the 16? 4 times what? 4 times 4. So, how would I write the exponent form? How many 4s am I multiplying?
4, and then a mini 4 on top.
How many 4s am I multiplying? 2.
Oh.
So it's going to be 4 to the second power because I'm multiplying 2 of them. It's how many I have. For the next one, I have 4 to the third power with exponent being a 3. What is that going to be as a product? What am I multiplying, Felix?
4 times 4 times 4.
That's it. So the product form or factor form is going to be 4 times 4 times 4. Now, I need to do a little bit of work to find the answer. So on the side, if I have 1 4, it's just a 4. If I have 2 4s, I know that's 16. Now I need to figure out what 3 4s would be. If this is 2, how would I get that? I do 16 times 4. So I'm just going to take that answer and multiply it by 4. And you do get 64 because 6 times 4 is 24. Carry the 2. 4 times 1 is 4 plus 2 is 6. So over here, I'm going to put the 64. What am I going to write as an exponent? What is this going to be an exponent form? It's going to be what, Tony?
4 and a small 4.
Yeah. It's going to be 4 to the fourth power. How am I going to find the answer? What am I going to do with the 64? Times what? 4. 4 times 4 is 16. Carry the 1. 4 times 6 is plus 1, 25. So you have 256. So I come back over, and I'm going to put 256. What am I going to write as far as the product of this? If I have 4 to the 5th power, tell me what to write. I'm going to do what? Aubrey. I need you to tell me what to write specifically. I have 4 times.
4 times 4 times 4 times
That's it. 1, 2, 3, 4, 5 of them. How am I going to find the answer? How am I going to find the product?
You can do 4 times 4, that's 16.
Don't I already have this? So what am I going to do to find the answer? Times it by another 4. Because I already have this is 4 of them, so I know all of this is 256. I just have to multiply by another 4. So 4 times 6 is 4, carry the 2. 4 times 5, on the side, you need to be writing this down. Plus 2, 2, carry the 2. 4 times 2,
8.
plus 2,
9. I'm 10.
10. So that answer is going to be 1,024. Questions? Now, what are we going to do with this information? Well, we're going to combine what we know about prime numbers. We're going to use the exponents to write some of them if we have the same factor repeated. We're going to look at something called prime factorization. So on 36B, prime factorization. Prime factorization. We are going to break composite numbers into all prime numbers. So to do this, I know that prime numbers are circled. Didn't we circle all the prime numbers in our chart?
Yeah.
Okay, so if we have a prime number, we're going to circle it. I need to have 2 numbers. One is prime, one is composite. What number do I know I can divide into 125 evenly if it ends with a 5? A 5. So 5 times what number is 125? I don't know. So I might have to do some work. I don't have my times tables memorized that high. Does 5 go into 1? Does 5 go into 12? How many times? 2. What's 2 times 5? 10. What do you get when you subtract? What do you get when you subtract? Pass that down. I will post the video later for you to finish your notes. Okay. All right. So I'm ready. Take away 10 from 12. What's left? 2. Now what? Bring down the 5. How many 5s are in 25? 5. So 5 times 5 is 25. So I go back to the question. 5 times what number is 125? 25. I put the 25 in this because I'm putting only prime numbers in the circles. Is 25 prime? Is it marked out? Why is it marked out? What does it end with? So what times what? 5 times 5. Now, notice that the answer to this, only looking at the prime numbers. Write down, babe. You're just copying. Okay, I'm just giving you some helpful information. You got to do your homework tonight. It is using this. So my prime factorization would be 5 times 5 times 5. Can I write that in a shorter way with exponents? What's my base number? What number am I multiplying? 5. What is my exponent? How many 5s are there? Count them.
3.
So that's your exponent. It's 5 to the 3rd power. This is not difficult if you can count. And I really am not going to have you count more than one hand. Great. we're going to finish this page. Then you won't know how to do the homework that you have to do. All right, for number 2, I have a 30. I need to break this into 2 numbers. One of them has to be prime. There is many different ways I could break 30 down. Give me 2 factors for 30. Mia Lynn, what times what is 30? Times is 35.
No, that's it.
Okay, so which of those 2 numbers is the prime number for me to put in the circle? 5 or 6? Okay, so I'm going to put this as a 5 because I can't break it down. Jackson, writing this down. Then in the box, I'm going to put the 6 because that can be broken into what? Times 2. I'm not going to put 1 in any of these boxes because 1 is not a prime or composite number. So it has to be a prime or composite number. This shows that it's going to be 3 times 2 times 5. That's how we are going to find the prime factorization. It's only prime numbers. What happens if I multiply this? I'm going to get 30. Okay, next one, I have 105. What number do I know it has to be divisible by? 5. All right, so now in this box, how many times does 5 go into 105? How many times does 5? I can do it on the side. How many times does 5 go into 10? 2. How many times does 5 go into 5? 1. So 5 times what number is 105? 21. Is 21 prime? No. So what times what is 21? 7 times 3. So then the prime factorization for 105 is 3 times 5 times 7. Now, this is one method. There's another method that you might like better, but you will have a choice. So it's called upside down division. You must use a prime number to get started. Okay? So I'm going to go back. Same number. What number do I know goes into 125 that's prime? 5. Okay? Then I'm going to put, instead of on top, underneath. How many times does 5 go in 125? So you're going to put 25. You're going to keep breaking this down. Write this down, please. Until you only have a prime number. Is 25 prime? Okay, so you are going to divide again. So it's like an upside down division sign, Milan. Upside down division sign. On the outside, what is a prime number that goes into 25? 5. How many times does 5 go into 25? 5. Is 5 a prime number? Notice, all of these prime numbers are the same as what we ended up with here using upside down division. So it would be 5 times 5 times 5, which is the same as 5 to the 3rd power. All right, for this one we use 5 to get started. Let's use a different number. What's another prime number I can divide into 30 besides the 5? Summer? You have them right here. Is not prime. I cannot divide, say it again. I can do 3. So if I divide 3 into 30, how many times does 3 go into 30? So then I put the 10 underneath. Is 10 prime? I've got people not paying attention, and that's concerning, gentlemen. Focus. Okay, so I am going to divide by a prime number. What's a prime number that I can divide into 10? 5. How many times does 5 go into 10? So, notice, same prime numbers. It's going to be 2 times 3 times 5. Same thing that we had over here. It's just a different way to do it. With number 3, before we had used 5. Instead, let's use 7. How many times does 7 go into 10?
3 times.
How many times does 7 go into 10? 1 time. Okay. Then I have a remainder of how much? There's going to be 3 left over, right? That makes 35. How many times does 7 go into 35?
5.
Okay, so notice, how many times does 7 go into 105?
15.
15. Is 15 prime? No. So I'm going to divide by what number? I need a prime number to divide. I can do 3. How many times does 3 go into 15? 5. Is 5 prime? I'm finished once I get to a prime number. Notice it's the same 3 numbers we got here. Raise your hand if you like the factor trees better. Raise your hand if you like upside down division better. You can choose. Now, if you can't think of a prime number to get started, for example, 24. If I have 24, I can break that into 2 composite numbers. 4 times 6. Are either of those prime? Are 4 or 6 prime? So I cannot circle them. If they're not prime, I have to break them down. What can I break 4 into? 2 times 2 is 2 prime. I can circle it. Is 6 prime? No. What times what is 6? 2 times 3. Is 2 prime? Is 3 prime? So you can use 2 composite numbers with the factor trees. If you're doing the upside down division, Sydney, stop please, then you want to use prime numbers only. So if you're not sure of that, you can always use the factor tree to break it down. Now, to understand what to do on the homework, I'm going to pass it out. Don't put it up because I want to look at some questions on this to help you to get started. Right now, I don't want to hear any of that because it doesn't sound very common.
Oh my God.
Okay, so that's why we're going to go over it. So at the top, you are just on the front, breaking them into prime factors. Okay, just like we did. You can use factor trees or you can use upside down division. What do you notice at the bottom? There's letters. So let's look at some of them. Let's look at 14. Let's look at 14. Let's do the number part. What's 2 times 5? What's 10 times 5?
10 times 5
Is 50. So if I have 50 for my number, how many x's do I have? I have 2 x's. What am I going to put for an exponent? X to the what power? To the second power. We're going to do x to the second power. Alright, so I have some letters involved. How do I get the exponent? I just count, right? So, the numbers you get by just multiplying. The letters, I have x to the what power? To the second. Do you see that in the list?
Yeah.
Yes, it's right there. So you're counting. The numbers you multiply, the letters you count them. Questions, not hard. If I look at this, we have some exponents involved. So let's talk about it. What's 5 to the second power going to equal? No. What's 5 to the second power is?
5 times 5.
What is 5 times 5?
25.
Okay, so this is 25 times 2 is what? You have 2 quarters. What do you have? 2/4 is what? 50. And you only have a squared. Do you see that?
Yeah.
Don't make this difficult. Okay? You're just doing the basic multiplication, and the letters are really just counting. These, you're just putting the numbers together. On the back. Should look familiar. Divisibility rules, just like we did on that half sheet. Questions? Okay. So, if you are